Let's take a look at how to create a MATLAB function, how to save that MATLAB function in a particular folder, and how to set the path to that particular folder so you could use the MATLAB function from any current folder location. Okay, to create the function, go to your Home tab in your tool strip, select the new icon, do the drop down, and select Function. Now note, this is not the live function, this is a regular MATLAB function. Our template shows up. It has the keyword function and the keyword end. It's best practice to use the end to terminate the function. So they're a matched pair, and you can see the outline here. There's some minus signs here. We could collapse that. You even collapse the function, and you see the ... ellipse icon, or expand them all. So this template is a generic template for 2 input arguments and 2 output arguments. In general, a MATLAB function can have actually return no values. It can return multiple values, as in this case, or it could return 1 value. So this function that we're going to create, I'm going to name it area circ. So the generic name here, untitled, is area circ, because this function is going to calculate the area and the circumference of a circle and return those values to the function call. The only input required to calculate the area and the circumference of a circle is, the radius, right? So I created this variable named RAD, and if you notice, the little message pops up, and I could do a Shift Enter, and it updates all the previous input argument number 2 to the current variable named radius. It's a good practice to use to help minimize spelling errors. So my function area circ is going to return an area. I'm going to create that variable name for the output argument number 1. Again, I'm going to do the Shift Enter, and output argument number 1 is going to be updated to the variable name area. I'm going to change output arg number 2 to CIRCUM for circumference. And again, Shift Enter, following the tip on the screen, to update the variable names. So now I just have to create the expressions for the area. And what is the area of a circle? Pi times radius squared. Now notice I did use the element-wise operator because I want to have the ability for the user to pass in a scalar or an array for the variable RAD for the radius. And then the circumference calculation, 2 times pi times radius, RAD. Now it's important that you include the comments for the function, and that's why they're highlighted in this template, and it gives you a hint here. Summary of the function goes here. So this should just be a brief summary. So area circ, what does it do? Calculates the area and calculates the area and the circumference. Very brief, high level. Now we have an opportunity to provide details. Radius is the input. array or scalar. Returns area and circum. And what else do I want to put here is format. How is the user going to call this? Well, the user is going to call this function by creating an expression, and I'm using A and C as an array because the function is returning two values, the area and the circumference, and the user has to call the function name, and the user would then pass in the value for the radius. Now I like to indent my expressions within the function and end just for clarity. So now where are we going to save this? If you notice, the function name, the function header has the area circ here, but it's still, I haven't saved anything yet. So I want to save this at a particular location. I want this file to be accessible that I could store all my functions in. And that way, wherever I am in my current directory, I could have access to all my functions. Because remember, you could only run programs or functions out of your current directory in the desktop, we'll see shortly. So this is a little bit different in this case, so I'm going to do save as. And I'm going to browse to a folder called MATLAB functions. So my file name is area circ. So MATLAB completed that for me. It's an M file type, so now I could hit save. And now my file is saved in the directory. If I go back to my desktop, if you notice, my current directory here is MATLAB work, and there's no programs or no files in my current folder. And if I try to run my function, I'm just going to put a value of 1 for my radius, I receive an error, right? Because it's not located in my current folder. So how we could fix that, if we go up to the tool strip in the Home tab, under the Environment section, there's an option for Set Path. Select Set Path. Now, I want to add a folder, and the folder I want to add is where I saved my function, which was MATLAB functions, right? So here it is, and I select folder. So here you notice, here's my drive. My folder is MATLAB functions. It doesn't show me any items in the folder because I'm only selecting a folder. It's not showing me what's in there. I'm selecting the folder only. If I select that, you see now it's in the path, MATLAB functions. Now I simply save, close, and if I try to run my program again, calling my function again, I'm calling my function area circ, and I get the results, right? So even though it's not in my current path, my current folder, rather, it's still my search path. So wherever I go, my current folder, when I call my function, it is available for me to use. Now let me demonstrate why the comments were so important if I use help. If I forget the details on how to run this complicated function, I know that the function name is area circ. Area circ. So I'm using help. I'm typing in the function name. And here, it's displaying exactly the comments that I've added to the function itself, right? And this is consistent with all MATLAB built-in functions. So for example, if I type help min, which is a built-in MATLAB function, what does it tell me? In this case, the comments and the detailed explanation are very detailed because min, even though it's a simple function, it tells me what's the overall brief summary. Min, at minimum elements of array. That's what it does. Now, the second and remaining lines are the detailed description. So I could say m is equal to mx is the smallest element of the vector x. If x is a matrix, m is a row vector containing the minimum element from each column, right? And so on and so forth. So here's all the details of explanation for any user could refer to the help function name and know exactly how to call that function. And in this case, you see they even provide an example on the syntax versions through the help. So you should always include those comments in your functions to provide the summary of the function and the detailed explanation. Because if you think about it, that really makes sense and it really helps you out, is because it's not your functions are not going to be in your current folder. So if you have to go and browse to that folder location, browse to that current folder location, open up the function, examine it, and then learn how to use it. And then you got to close it, browse back to your current folder location, and then you could proceed with your programming. Well, in this case, you could just use the help function and the detailed explanation come up to you whatever current folder location you're running the function from or calling the function from. So if we go back and take a look at that function, one thing that I would encourage you to also add is the date that you created this function, your name as the author, and any copyright information, copyright date, all rights reserved, and to protect your intellectual property. The help functionality only displays the continuous comments after the function header. So for example, if I create a space and I add a date, today, I could save this. Now if we go back to the desktop, run the help, notice nothing's changed because there's the date comment was not continuous from the comments under the help function header. And we could even demonstrate how this works and demonstrate maybe my comments were not detailed enough. Because what if I have a matrix of numbers for, in this case, the radii, right? So I have a 2 by 2 matrix, 1, 2, 3, 4. When I call my function, I'm expecting to get the function to return the areas and the circumference. So what happens? Let's take a look when I call the function. Well, sure enough, right? I have a matrix of areas and I have a matrix of circumference. So the function does indeed work for both scalars and matrix.